Hello and welcome to Math Lessons with Linda. Today's topic is finding the domain of a function algebraically rather than graphically. There's a previous video that has a couple of examples similar to this, and today we are going to wrap up how to do this particular type of problem with one other example. Here is our function today. G of x is equal to the square root of 7x minus 70. So in a radical, when I see a radical in any kind of a problem, whether or not it has a variable in it or not, the one thing that I know is true about a radical is I cannot have a negative number underneath, that's a negative number under the radical. So that tells me I could have 0 and anything bigger. I can take the square root of 0, I would just get 0. And then of course, anything that's larger than 0 in the positive direction, I could also take a square root of. And my only restriction is that I can't have it be less than 0, right? So what I would say in terms of figuring out what this would be is my 7x minus 70, whatever this turns out to be, depending on what I plug in for x, it would have to be greater than, or it could be equal to 0. That will rule out any possibility of getting a negative number under your radical. So if this is what my restriction is, I'm going to solve my inequality and then figure out what values I can use for x. So I'm going to add 70 to both sides. So I get 7x is now greater than or equal to 70, and divide both sides by 7. So x just has to be greater than or equal to 10. Anything 10 or larger. If I am writing my solution in interval notation, that means since it's including the 10, that's when we use the bracket for our lower value. So it starts at 10 and includes it, and it's anything bigger than that. So that means it's going to go all the way to infinity. And if you would like to pick a number that is in your interval, just to double check that you get a positive number underneath your radical, you can certainly do that. You could plug in 20, and I would get 7 times 20 would be 140. 140 minus 70 is 70. It's not a perfect square in this case, but I know I'm going to be able to take the square root of 70 as it would be a positive number. So this is one last example of how you can find the domain of a function algebraically using a radical equation.